So, questions on the homework. Properties of rational exponents. None of these are new. None of these properties of rational exponents should be new. We've covered them before, either in here, in Algebra 1, geometry. We've talked about properties of rational exponents. Product of powers. If we multiply like bases together, we add the exponents. Power of a power. When we have a power of a power, we multiply those powers. So a to the m to the n is a to the m times n. Power of a product. If we have two things being multiplied together, put to that same power, we can rewrite it as both of those terms to that power. We can apply that power to both terms. Negative exponents. If an exponent is negative, to make it positive, we move it from the top of the fraction to the bottom or bottom to the top. Zero exponent. A to the 0 is equal to 1. The only exception is that a cannot be 0. 0 to the 0 does not work. There is no value for it. Now, it does come up in calculus. We do take limits or approximate limits of 0 to the 0. As numbers approach their converge there are special cases with it. But in the general sense, 0 to the 0 does not exist. Then we have a to the m divided by a to the n. When we divide like bases, we subtract the exponents. And power of a quotient, when we have two things divided to a power, we can apply that power to both terms. Power properties. We've done these before, we've gone over these before. And we're going to do these here. Simplest form. Really, this is not going to come up too much. I think I've said it year after year. I'm going to remove it from this slide and put it where it needs to actually be. But as you can tell, I have not done that. But if a radical, this is mainly focused on our radicals, our square roots, cube roots, fourth roots. A radical can be said, it's in simplest form, if 1, no radicands have perfect nth powers as factors other than 1. What this is saying, we cannot leave our answer as a square root of 4 for sure, because the square root of 4 is 2. When we leave it in simplest radical form, we cannot leave it as the square root of 8. It does not work, because the square root of 8 has a perfect nth power, a perfect square root in it. So we cannot leave it as that, because the square root of 8 is actually going to reduce to 2 square roots of 2. It can be simplified. If it can be reduced, if we can pull factors out, we're going to have to. No radicands can contain fractions. We can't have the square root of 1/3. We cannot have this. We have to simplify. We have to reduce it, and it ends up becoming square root of 3 is how we have to actually rewrite it. And we'll go into more depth of how we get there. And no radicals appear in the denominator of a fraction. We can't have 1 over the square root of 2. We cannot have this. So as long as one of these 3 does not show up with radicals, we're good. But again, today we're not talking so much about radicals as properties of our exponents, exponential properties. So the first one we have here is 7 to the 1/4 times 7 to the 1/2. When we multiply like bases, we add the exponents. So 7 to the 1/4 times 7 to the 1/2 would be 7 to the 1/4 plus 1/2. 1/4 plus 1/2 is 3/4. Telling us that this is 7 to the 3/4. Questions on this so far? That's it. Use the properties to simplify its expression. We're not solving, we're just simplifying, so it's 7 to the 3/4. If we can simplify and multiply farther than that, we will, but this is as far as we can take this one. Questions on A? B, we have a few things going on. One, we have a power of a product. Power of a product. We have two things multiplied together to a power, so we're going to apply that power to both of them. So we're going to have 6 to the 1/2 to the second times our 4 to the 1/3 squared. We're applying that power of 2 to both terms. But that also gives us a power of a power, which means we're going to multiply those powers together. So we'd have 6 to the 1/2 times 2 being multiplied by 4 to the 1/3 times 2. Well, 1/2 times 2 is 1, giving us 6 to the 1st, or we can just say 6, times 4 to the 1/3 times 2 is 2/3. That's it. Question on A or B? B is as far as it goes because 4 to the 2/3 is as simplified as it gets. It doesn't reduce. I mean, we could rewrite it as 2 squared to the 3/4 or to the 2/3. That would give us 2 to the 4/3. It's not any simpler. It's not reduced any further. Doesn't help us. Let's look at C. 4 to the 5th times 3 to the 5th to the negative 1/5. Now, there's different ways we can go about doing this. If we use product of a power, we can say that we have 4 to the 5th to the negative 1/5 times 3 to the 5th to the negative 1/5. We can apply that power to both terms that are being multiplied inside. Powers of power says that we multiply, so we'd have 4 to the 5th times negative 1/5 being multiplied by 3 to the 5th times negative 1/5. Five times negative 1/5 would be negative 1. And we'd have the same with 3. So we have 4 to the negative 1st times 3 to the negative 1st. But we can't leave that exponent negative. We've got to make it positive. And to do that, we're going to move both of those terms to the bottom of the fraction, which would give us 1 over 4 to the 1st times 3 to the 1st, or 1 over 4 times 3. We don't have any exponents anymore other than 1, and 4 times 3 is 12. So we get 1/12. Questions on this here? And yes, we could have done that a little differently. Because both of these have the same exponent, I could have also used product of a power backwards. Instead of applying it to both terms, we take it away from both terms. Powers of powers multiply, so we'd have 4 times 3 to the 5 times negative 1/5. 5 times negative 1/5 is still negative 1. Why not? 4 times 3 is 12. So really telling us that we have 12 to the negative 1, which is still 1/12. Different ways we can do it. It just depends on how we want to apply each one of our properties in what order. Let's look at the next ones. D. 5 over 5 to the 1/3. Well, the numerator is 5 to the first. When we divide like bases, we subtract the exponents. And as we do this by the property, we have the exponent on top minus the exponent on bottom. So we have 1 minus 1/3, which is 2/3. And since that exponent's positive, it stays on top. We don't have to move it. If that exponent had been negative, we'd have to move it from the top of the fraction to the bottom and go from there. But it's positive, so it just stays 5 to the 2/3. Questions on this here? E, 42 to the 1/3 divided by 6 to the 1/3 all over 2. Is 42 divisible by 6? Yes, no. I don't know. Well, we can check. And the reason I bring that up is because we do have this fraction, we have exponents or fractional exponents on top and bottom, and specifically they're both to the 1/3. So it'd be nice if 42 is divisible by 6. And since it is, we can use our quotient of a power property that says if we have two things being divided to a power, we can apply that power to both terms, that same power to both terms. The converse is also true. If we have two terms being divided and they're both put to the same power, we can pull that power back out, giving us 42 over 6. And 42 divided by 6 is 7. We don't have a fraction anymore. It's a lot nicer and easier to work with. Powers of powers multiply, yes? And it doesn't matter the fact that I actually have 7 to the first, to the 1/3, to the second power. We can really just say this is 7 to the first times 1/3 times 2, which would be 7 to the 2/3. Now the question might come up, I'm not sure if I did that right. Well, 42 to the 1/3 over 6 to the 1/3 squared. 42 to the 1/3 over 6 to the 1/3 squared is, and we said it's the same as 7 to the 2/3, yes? I'd say those are equivalent. So that means they're the same. Questions on this here? 2 to the 3/4 times 2 to the 1/2. Well, this would be the same as 2 to the 3/4 plus 1/2. 3/4 plus 1/2 would be 5/2. We could do 3/4 plus 1/2 in a calculator. It will tell us immediately what it is. Questions on this here? 3 over 3 to the 1/4. 3 divided by 3 to the 1/4. When we divide like bases, we subtract the exponents, telling us that we have 3 to the 1 minus 1/4. 1 minus 1/4 is 3/4. And we could do the same thing we've been doing or done before. When we divide like bases, we just subtract the exponents. If it's bigger on top, it stays on top. If it's bigger on bottom, it stays on bottom. That still holds true, but sometimes with fractional exponents instead of integers, it's a little bit nicer to actually write it out in proper form. Questions on 1 and 2 before we look at 3 and 4? 3 has a fraction, and normally I would leave it alone. We'll leave it in fractional form unless the denominators, or the bases of both of these terms are divisible. Is 20 divisible by 5? Yes. And since they're both put to the same exponent, we can use the quotient of a power to pull that exponent out. And we can only really do this if they're either A, the same exponent, or B, we finagle it enough to be able to pull that power out. And 20 divided by 5 is 4. Giving us 4 to the 1/2 to the third. Powers of powers multiply. Telling us that we have 4 to the 3/2. Questions on this here? Number 4, 5 to the 1/3 times 7 to the 1/4, all to the third power. Now the previous one we had like this. Like see here where they're both put to the 5th power, we cannot do the same thing of pulling that 5 out this time, because both exponents are not the exact same inside the parentheses. So all we can do is our power of a product, which means really we're saying that we have 5 to the 1/3 cubed times 7 to the 1/4 cubed, or really powers of powers multiply. We're really just multiplying those exponents. 1/3 times 3 is going to be 1, leaving us with 5 to the 1st. 7, or 1/4 times 3 is 3/4, telling us that we have 5 times 7 to the 3/4. That's it. Questions on these here? Do we need to see another example of any of this? Feel pretty good with this here. 3 through 10.